In this video, I will introduce you to circular motion. Here we have a point object. Let's consider this to be the buggy that we saw in the last video, moving around in a circle around a ring stand because there was a rope attached to it. And sometime later, maybe that buggy will be up here. Sometime later, maybe it will be down here. At any given point, its velocity, the velocity of that buggy, is tangent to the circular path that it's moving along. So that's thing number one. And then we also saw with the buggy that the tension force was pulling it in toward the center of the circle. So in the case of that buggy, there was a tension force pulling it in toward the center of the circle. This is a bird's eye view of the buggy. Let's write that down. Bird's eye view of buggy pulled into circle. Not circly, but circle. Pulled into circle by rope. And so this was what our picture looked like. And coming out of the screen, you would have the normal force on the surface, and digging into the screen would be the gravitational force because it's the bird's eye view. But those balance each other out in this example, so we will leave them undrawn. Due to just the nature of these vectors that we've drawn so far, it'll be helpful to choose a special reference frame anytime we're talking about circular motion. We should choose the reference frame where one of our axes points radially inward toward the center of the circle, and our other axis points tangential to the circle at a tangent. So we'll call this the R direction, and we'll call this the T direction, where R stands for radial direction along the radius, and T stands for tangential direction. It is not a time axis in this case. Both of these are space axes. Just one is in the direction of the radius, and then one is perpendicular to that tangent to the circle. So that's going to be our reference frame choice. Because we can see that now the axes of a reference frame line up well with the forces and velocity that are there. Let's generalize the principle of the buggy now to something that's moving in a circle, just more generally. So I'm going to now scroll down, and let's state some facts. One fact is that in order to turn in a circle, there must be a net force in the radial direction pointing toward the center of the circle. So that's fact number one. Fact number two that we can extrapolate from that buggy example is that the velocity always points in the tangential direction. A consequence of this is that if the net radial force disappears, then the object will just move in a line. So no longer in a circle, but in a line, tangent to the path. Tangent to the circle. Tangent to the circle at the point where the force was lost. At point where force, we'll say, stopped. It'll maintain that constant velocity from there. So that's consequence number 2 from our buggy example. And then fact number 3 that we're going to have here is that since there is a net force in the radial direction, there must also be a radial acceleration. A radial acceleration, which we will call A subscript r, toward the center of the circle. Scrolling back up to our original picture now, that means we can draw an acceleration arrow into this picture also. And it would be the radial acceleration that's there, pointing in the same direction as the net force toward the center of the circle. Now, this is the type of acceleration that turns an object but does not make it faster or slower. This acceleration in other words, this acceleration changes the direction of the velocity. But not its magnitude. Not its magnitude. So this object is not getting faster or slower with just a radial acceleration, or just a radial component of the acceleration. Component of acceleration. All right. And those are the 3 key takeaways that we can get from this picture here. Is that the net force needs to point toward the center of the circle, therefore we'll have a radial acceleration toward the center of the circle, changing the direction of the velocity, in this case from maybe up and to the left, and then just to the right, and then down and to the left, right, it keeps changing. I think that's where I want to end this video. We'll look at some more examples in future videos.